through it. Trig in the past, do you remember SOHCAHTOA? A lot of teachers use SOHCAHTOA, sine, cosine, and what's the third one? Tangent, right? Tan, sine, cosine, tan, tangent, right? So I kind of will still tell you that those work, but they don't work in all cases, okay? So get ready. Okay. So if you have a highlighter, get that ready as well. Okay. So the two main things in this unit will be sine law as well as cosine law. Okay. Sine law versus cosine law. So you need the notes from yesterday, the booklets. If you didn't get them, they're up front here. The test, I'm going to try my best to have them done by tomorrow. Right? But here we are, Trig. We're starting Trig chapter 7. So we're going to start with the sine law, and then after a couple days, we're going to start transitioning over to cosine law, and then you're going to have to pick which one am I going to use. Because only one of them gets you started. You cannot start with more than one. Okay, that's the key here. So sine law first, since we're working primarily with oblique triangles, right? What is oblique? That's a fancy word for triangles that are not right triangles. Okay? We will not be using primary ratios as you learned in previous years. SOHCAHTOA, right, will not work in most cases. Do not use them. Okay? Like this, right? If you have a triangle like this, or if you have a triangle that, you remember the roof questions like this, and you would have to split it in half, right? Then this SOHCAHTOA works for this. Okay, but the problem comes along when, just quiet, okay guys, we're starting already. Watch your time, guys, because I get going right away. Grab a seat and grab those booklets from yesterday. If you have an oblique triangle like that, or something like that, okay, SOHCAHTOA does not work in these cases, okay? Those are oblique triangles. So that's when we need to use sine law, cosine law. Okay. Let me just move this a little bit here. Over. So let's get started. If you have highlighters, more than one color is great. Remember I said 4 is ideal. And we're going to start with a little bit of review. So prior knowledge, you should know this already. Sum of interior angles is always 180 degrees. Okay. Why is that so important? Because if I have a triangle like this, right, and I know that this is 50 and this is 30, then I automatically, right, this is the one that's unknown to me. I will always just go 180 minus 50 minus 30. And what is that? In this case, 80 take away from, right, this is 80 take away from 180. You're left with 100 degrees. So you can easily find a third angle if you know that property. Okay. We have 3 types of triangles that are key to us. An isosceles triangle, what's so special about it? It has, what's that? Not quite. That's two sides are the same. So I'm gonna use make sure you understand that. So we are always used to these two being the same, right? But it doesn't matter. It could be these two, right? And so you would be looking for the markings like that. If you have two markings that are like that, that means that what? The angles, listen carefully, the angles across these two sides are equal. So what you do is you go across, so this angle will be the same as this angle. Okay, so check for the sides and then go across them. Those two angles are going to be the same. You're guaranteed that that's going to be the same. So two sides. This is the symbol in math for congruent. It's a fancy word for saying things are the same. Okay, and two angles are congruent as well. Okay, equilateral triangle. That one is the easiest one of all. Okay, all sides are the same, therefore all angles will be the same. I'm going to go back to isosceles real quick. If you see in math, like this has one arc like that and another arc, that's telling you these are the same. So this one would not be the same, correct? So we do this. So you're saying these are the same, this is different than the other angles, right? So that's quite often how we distinguish. So here all three are the same, all three sides are the same. So all sides are congruent, all angles are congruent, and angles are equal to what in an equilateral triangle? 60. It's always 60, right? 180 split in 3, right? Is 180 divided by 3, which is 60 degrees. I'm going to be very picky with the degree symbol. If it's an angle, it's always in degrees, okay? So we've got equilateral, no surprises there. Then you have your classic right triangle. Like that or like this. If you see that box, what does that mean in math? How many degrees? Yeah. 90, right? With this one, you can use, do you remember Pythagorean theorem? You could use that with right triangles. So we will sometimes cut things in half, okay? These two are symmetric. It's a little busy here, but what does symmetric mean? If something is symmetric. Yes. Okay. Meaning you can cut them in half. There's a point where you can cut them in exactly two halves. So those two, you can do it, right? Okay, next. Supplementary angles, what is that? If things are supplementary, anybody remember? This is good old grade 7, 8, 9 kind of stuff. What does it add up to? Supplementary angles would add up to 180. Yeah. So two or more angles whose sum is 180 degrees. You got it. Okay. What's the other one that adds up to 90? Starts with a C. Complementary. Do you remember? You know how an easy way to remember it is right to complement someone. Right? It's right to complement. So 90 complement, right? 90 complement. So you know supplementary is the 180. So this is what I mean by that. If you have a ruler, if not, just try your best. But let's say you have a straight line like this. Okay, let's focus in on that straight line. At any point on this line, I can be like, okay, right here. If you consider that point, what do we know about, because right now you split this into two arms, correct? From this arm all the way to the other arm, how many degrees would it be? 180, right? So if you come along and split that, right? If you split that with a third arm, right? If this is 50, you can automatically say that this side is 130, right? So, and you're like, I know this, Mr. Dirksen. Why are you making such a big deal? Because this is going to help you later on, okay? So let's do another one. If you consider this, right? And that's your straight line there. And any point on that line, I break it down into two arms. So that I know is 180. I'm actually going to break this into more than, so let's say we do this, and I grab another one, goes like this. So if I know that this is 80 and this is 30, what can I say about this one here? Really what you should be doing as well. I know that it's 180 across this line, so I'm going to subtract what I know. I know this 80 and I know the 30. So that gives me 70 degrees. So using that property allows you to find missing angles. And this is going to be hidden. It's going to be a golden ticket to solving problems. The properties like this. Okay. And you're like, okay. So here's the one example. This is a classic, so copy this one down. This unit has very few formulas, guys. There's only two really big ones, and then everything else is just steps. But let's say you have this triangle here, and I tell you, hey, this is 120 degrees. Okay. And you're like, well, it's outside the triangle, but you should recognize, wait a minute, I see a straight line here. I know that from this leg, right, like basically this side of the triangle cuts that. And so these two should add up to 180, right? So I go 180 minus 120, you end up with the 60 degrees that goes in there. And now you have an angle that's inside the triangle, which is going to get you started towards solving that triangle. What does solving a triangle mean? Because it's going to happen quite often. Solving the triangle. Okay. What were you going to say, Mason? Same thing? Finding all sides, all angles. Yeah. You know who uses this a lot? Plumbers and basically construction workers. They rely on angles a lot, right? Notation. I need you to know this here. If you are, how should I say this? I want to help you out here. Yeah. So I'm gonna do this because I want you to be successful when it comes to these. So let's say you have something like this. Let's try this. Right? So draw a triangle with a bit of an extension there. And put like dots on all corners, even here at the end of that little tail. Okay. And let's add letters. We usually have capital letters on the outside. Those represent the intersections, the points of intersections. Okay. if I wanted to make reference to, pay close attention, if I wanted to make reference to this angle right here, because remember the angle is the opening that is existing between these two sides. How would I refer to that one? And that's the problem right here. How many angles are attached to this point? There's one here and there's one there. So 3-letter notation. Yes, you need to, it doesn't matter which order you do this in. If you want to start here, you got to go angle B, C, D, right? Does that make sense? Or you want to start here, or angle D, C, and B, right? So you kind of are making that angle. So it's definitely referring to this angle right here. Okay. However, I personally dislike 3-letter notation with a passion. Like I can't stand it. It really like gets me like, wait a minute, is this the one? So as soon as you identify which one it is, you're gonna put a letter there. Let's say we call this angle X. So now, right, you say, hey, this is really angle X, which I can clearly see is there. And so from there on in, I don't use the 3-letter notation anymore. I just use my variable that I've associated. All right? It's just much easier, but you need to know how to read it, okay? Can you call angle A? Can you just say angle A for this one? Absolutely, because there's only one, okay? So let's do that. Angle A is the same thing as, how could we use a 3-letter notation for this angle? BAC, yes. BAC, which is the same thing as CAB. And so I'm going to use, so in this case, there was no need to use 3-letter notation, but you still could. Sorry, guys. Got it? It's not too bad if you just know your stuff. But this is going to happen, and some students either get it wrong or they just leave it blank. Because it's like, I don't know how to do this. I don't know which angle you're talking about. Because I will give you a word problem, and I will just use 3-letter notation, and I will give you a partially filled in diagram. You have to put that number in the right place. Okay? I think you can handle it. You're smarter than you think. Anyways, angle of elevation depression. Do you remember that? Grade 11? Okay, so I want to make sure you know the difference. Okay, so look at my amazing visual representation here. You can't get any better than this. Okay, so the angle of elevation and depression is always measured by starting with a horizontal line. And so for me right now in this diagram, it's going to be eye level. Okay, it could be the ground, you name it, but there needs to be a horizontal. So let's make sure we write down horizontal. It's the horizon. Remember, the sun sets at the horizon. Right? It's horizontal, and then there are two angles that can be formed between the horizontal. So I go back to there, use my ruler or whatever you have, go up. So let's say you're looking at a bird, or you're looking at a plane, a kite, blimp, sky, eagle, cliff. I'm running out of ideas here. But that angle right here is angle of elevation. Okay. So let's, and then let's pretend we need a ground, right? So let's pretend you're looking at a bug. Look at that. It's as good as it gets, guys. Some of you can whip up like a comic strip while you're listening to this. You're so good at this. So the angle between the horizontal and the line going down to this object, or in this case insect, it's the angle of depression. And I will, in various ways, test your knowledge of where do you put that angle if I give you that angle. Okay. Very important. So I think I'm going to highlight the horizontal. Okay. Maybe I will also say this common mistake right here. Somebody's at the top of a cliff. So this is the wrong image. Okay, so somebody's at the top of a cliff. There's a lake. So somebody's up here looking down at a boat, right? That's just sailing, right? So then I tell students, well, the angle of depression from the top to the boat is 50 degrees. So students are like this. Okay, there's my triangle. I'm gonna go like this. I somehow have a triangle and they put the 50 in there. What's wrong with that? Putting the 50 there. There's no horizontal, is there? There's no horizontal. So this is wrong. This is, what's the opposite of horizontal? Vertical. Vertical. This is vertical, so that you can't have it there. So this is the wrong, this is not angle of depression. Instead, what you need to do is you almost need to create a horizontal and put the 50 there, okay? That is where the 50 degrees, that's the angle. Did I say angle of depressions? Up here, it's just angle of depression. Sorry. So this is what I'm talking about, okay? Very important distinction because it makes the whole question wrong, okay? Anyways, keywords. Some more keywords. We have, obviously you know your north, south, east, west, right? I hope so. North, south. Where is east? Where is west? That's always the kicker. So this is what I tell my students. I know you have heard all kinds of different things to help you remember, but if you write E and W, it would spell ew, right? Ew. It's instead you want we, right? Anyways, hopefully that helps you. So a tree is due east of you. What if the question says a tree is due east of you? That means that you are here and the tree is going east of you. Okay, so the tree is east of where you're standing. Okay, so you need to know that. If someone travels, another example, if your speed is 30 kilometers per hour, fun, eh? Those 30 kilometers an hour zones. How far, right? How far in 3 hours? There's a question like this somewhere buried. If you travel 30 kilometers an hour, how far will you have traveled in 3 hours? How many? Close. 90, right? 30, 30, and 30? 90? 90 kilometers. That's the answer. So when they give you a speed and the time you traveled, right? If it's 2.5 hours, you just multiply it by 2.5, right? Okay, next page. Just a few things that are gonna come into play here. Okay, so this is where the formula for sine law comes in. I just thought of one more thing, sorry. Back to this page, back to this page. Sometimes I'm all over the place. This, I need you to know that this triangle would be called triangle ABC. That's different, right, than angle. Triangle ABC, we're talking the big, like the triangle that's formed here. So that's different than angle. It's just referring to that. This triangle, if you draw it, you got to make sure there's an A, B, and a C in each corner. Okay? X, Y, Z, D, E, F, it doesn't matter. Those are the letters that we're going to be using to make this triangle. All right? I think that's pretty straightforward, but I thought it'd be important to mention. Now, sine law. Here's the math, okay? You're waiting for the math. Here it is. The sine law, right, can be used to solve for unknown side lengths and unknown angle in an oblique triangle, right? And it only works in certain situations. Circle this. I will tell you the situations where that works. At the top here, at the very top of this page, write down nice and big sine law so that when you go, like right now, sine law, and for now it's just sides. This is on page 260, right? Sine law at the top, followed by sides, because I'm going to at first just solve side lengths, and then we're going to do angles in a bit. So very important for you to have that. Okay. So here we go. This is the formula for sine law right here. What is this saying? Well, I'll tell you that I'll use this where I use my highlighters, okay? The sine of angle A will have its side across from it, right? So notice that angle A is up there, side A is right here. So if you were to divide those two, that would be exactly the same as taking sine of B, right? So angle B right here, and sine B is right there. So they're across each other. Can we do an arrow like this? I'm going to go. That is convention in math. We use capitals for the angle, and we use lowercase for the side that's across from it. Okay. I can zoom in a little bit. I think it's a little bit small there. And I will do the same thing with the, hey, focus. That's like some of my students. Focus. Okay, so there's that angle A, side A across from it. And then the last one is C. Angle C is paired up with side C. I can't tell you how important that is to remember that you need to pair them up. Angle is across the side. They're paired up like that. So note on the top here, when solving, we set up one proportion sorry, you can't see that there, one proportion, and cross multiply, then divide. Okay, this is basically in a nutshell what we're going to do with sine law. And the second note here, capital letters, go for angles, lowercase, side length. So to make this abundantly clear, I will draw a triangle down here. Make it look not right. Not a right triangle. Okay. So if I told you, hey, we're dealing with triangle XYZ, and you can't see that part, can you? Sorry. If I told you, hey, triangle XYZ, then you go ahead and in no particular order, you can feel free to start anywhere you want. You will still get the same answer as me. That is key. If you have to draw your own triangle, just go ahead and start. Okay. So you use capitals for the angles. And now I'm going to fill it in with the side lengths, right? Capital X. So the lowercase x would go here. Lowercase y would go across angle y. Lowercase z would go across angle z. So that's very important to keep that in mind when you're doing these types of questions. Okay, calculator check. Calculator check. Set to what? You know this already. Set to degrees, right? Rad, grad, or radians, gradients is no, right? You don't want that. You want degrees. You want your degree and you want to graduate, but in this case, you don't want grad to show up on your calculator. So you turn on your calculator right now. Mine doesn't have a DEG. Mine only has a D. It's hard to see, but it's right there. Trust me. This is how you check to make sure yours works. Go sine of 30, sine of 30, and then hit equals. You should get 0.5. If you don't get that, then something is wrong with your calculator. Some of you have to type in 30, then sine. So you know who you are, right? You need to figure out your calculator. Most calculators that I have, you can go sine, then 30. But if you use your phone, which you're not allowed to use, right? But you know, I think you should still know how to use. Oh, I don't have the calculator app, which is weird. I have to download it. But anyways, you have to. Why don't I have a calculator app, right? What's wrong with me? But anyways, I have a scientific calculator on there, which is not the same as you have. Degrees is important, okay? So let's go and do some math now. I still want to tell you, oh yeah. Should I write it on this page? I will write it on this page, okay? Here it is. If you can find an angle side pair, use sine law. Okay. If you can find that pair, and you will know what I'm talking about as I do a couple of examples, right? You use sine law immediately. You stop, you're like, ah, this is sine law. I don't have to worry about cosine law here. So this is what I'm talking about. Do you see these two that are given? That's a pair. That I do this, and for a number of my examples, I will first do this, and that's your pair. Therefore, sine law. Okay. Why is there exclamation marks, right? Just pair, sine law. But anyways, so that's your pair. Keep that in mind. So now you're in sine law territory. Soon you won't be. You won't know, right? So they're asking for, it's saying to use sine law to calculate the length of side A. Let's pretend like they didn't tell us that it's sine law. It's like, hey, just calculate side A. What you should have done is immediately identified this and it's like, of course I have to use sine law. So just, I will not tell you down the road whether or not it's sine law, right? So you have to figure that out. So here is the math, okay? By the way, how many angles are known to us there? Yeah, immediately. Yeah, isn't it true? Like if they give you two, they're basically giving you all of them, right? So I will do this first. Can you always do that? If you have two angles, angle C is 180 minus 72 minus 52. That's right, Zach. I like that. I like that. If they give you two, they're basically giving you all, right? 56 degrees. So this is now known to us. I'm going to insert that here. 56 degrees. I just found that. I would encourage you to do that because sometimes you don't see the pairs there until you do this. And then you're like, yeah, I have a pair, right? So here we go. How does the formula go? This is how I do it. You go sine of B, right, over what has to go down here. If it's capital B, you'll put lowercase b underneath. That's my pair. Is equal to, what side am I trying to find? A. So I have to put that down here. Why is it down there, Mr. Dirksen? Well, because you put the side length on the other side, so you have to put A here. What would have to go up here? Sin A. But this is what a lot of students do. I don't know why. Maybe you're sleeping in my classes. I don't know. Don't sleep. They just go like that. It's wrong. Yeah, like it's wrong. And if you get some weird answer, it's probably because you made a mistake. Okay. So this is my pair. This is the pair that I knew, right? And this is the unknown. That is what they really want. Okay. So let's start. I'm going to start with my pair. Sine of 52 degrees over 16.8 centimeters. And on the other side, I do know what A is, correct? What would happen if I put 56 in here? Let's say you're not paying attention, you put 56 in here. What would you be finding? Yeah, you'd be finding that side, so that's the wrong side. You want to find this side, therefore you need to use 72. And so this is side A like that. Substitute, right? Substitute. You wish you had a sub in today, right? So you wouldn't have to listen to me. Sub, right? And so how does this work? This is too much, Mr. Dirksen. It's like letters and numbers. What's your unknown here? So you start on this side, correct? You would cross multiply which way? Yep, you multiply down and you divide up. Okay, no shortcuts here, guys. No shortcuts. You do not put equal somewhere on the side and give me the answer. You take the A and you tell me exactly what you're doing. 16.8, like these two are multiplying. Like that, and you're gonna type this in whether you like it or not. I will strongly encourage you to type this in and see if you get the same thing that I'm getting. So watch what I'm going to do. I'm going to go 16.8 times sine of 72. I hit equals, right? Multiply this first, then I go divide by sine of 52. Because remember, Sine of 72 and sine of 52, those are just numbers. Your calculator will compute them. So no need to worry about it. So that's 20.2, rounding, 28. Yeah, 20.28. 20.28 what? Degrees, centimeters. Yeah. Boom, you're done. Do not use SOHCAHTOA. This is not a right triangle. You can't do it, right? You cannot use SOHCAHTOA. Okay, how about this? I will ask you to solve for, go on the side, solve for side B. Guess what I'm going to do, guys? I'm going to use the pair that sorry, this pair is still true. So I'm going to start off with that again. But in this case, I'm going to use sine of 56, and I'm going to solve for B. Oh, sorry, you're right. Thank you for stopping me. Pause, right? Intersection. 56 is across C, right? So this has to be C. Yes, absolutely. B is over here, which is already used. You cannot double up on values, guys. It only shows up once. Okay. Good catch, good catch. So C, you do the same thing. You cross multiply, you divide. So it's 16.8, and you're probably wondering, why is it using this before that? Right? Why isn't it going sine of 56 times this? Because sometimes the calculators act up. Like sometimes when you do this, sine of 56 times 16.8, it mixes these up. So I like to first use the number down there and then go times sine of 56. Okay. So 16.8 times sine of 56 divided by sine of 52, that's 17.67 centimeters. Did you solve for the triangle at this point? You know all sides now, you know all angles. So you've actually solved the triangle. Yeah. How many things do you need to know minimum to get started? You need to know at least 3 things, right? If they don't give you enough to start, then you won't get it right. Observations. This is how you know you're doing things right. The largest angle will be across the longest side. Would you agree with that? That the largest angle would be across the longest side? Think about it, like the bigger the angle, right? The bigger the angle, the bigger the side across it will be. So smallest angle will be across shortest side. That, if you remember this, then you should hit equal on your calculator and right away be like, this can't be. I can't have it. Like, this is the biggest angle. How come it's shorter than the other side? Okay. So that's something to observe. I'm just going to put this in a box because it's important to keep in mind. I honestly think that after one example, you can already do this. So I will ask you to give this a try on the next page there, 262. But I'm going to put a twist to it. So you have to be ready for this. Backside, 26. I will ask you this. Calculate the length of all sides. All sides. So there's Z, and what would this side be called right here? X, right? And this down here would be lowercase l. And down on this third triangle, this would be lowercase r. Okay, so this is what I'm going to suggest. Solve for one side on the left, and then go over to the other side and solve for that second side on the right. What will you start off every time? What should be on the left side of your equal sign? The pair, right? The pair is the first starting point, and on the other side, you have to decide what's going to be there, okay? So I'm going to pause it. You give this a try, but at least you know the answer. So if you didn't finish this, make sure you write this down so you can give this a try. I want to see you as early as tomorrow on this, so be ready for tomorrow, okay? So this is just a triangle. There are no word problems yet, right? You notice that? So homework. Did he say homework? Did he just use that word? The H word? So homework up top here. Page 1. Is it just 1 or 2? 1 and 2. 1 and 2 workbook. And if you were here on time today, you know what I mean by workbook. If you were late, I mean this one. So I will try to look this up. I'm pretty sure I have the key somewhere. So if you think you know it all, maybe give it a try. Okay.